In this tutorial, we are focusing on y equals mx plus c in a little bit more detail. So if you've missed the basics video, please go back and watch that. In this lesson, we are looking at parallel lines and perpendicular lines. So if we consider the straight line y equals 2x plus 1, and we look at this on a set of axes. So we have a y-intercept of 1 and a gradient of 2. If we were looking at a line that is parallel to this, we would perhaps draw a line like so, or like so. So looking at this visually, what we can see is that the y-intercept is different, however the gradient of those lines are the same. So parallel lines will have the same gradient, however a different y-intercept. So for example, if we had the line y equals 2x plus 1 and we were asked to write an equation of a line that is parallel to that, we could say y equals 2x minus 3 or y equals 2x plus 10. Point being, the gradient is the same. If we were asked to give an equation for a possible perpendicular line, now perpendicular means to cross at 90 degrees at right angles to. So what we can see clearly from the pink line is that they do not have the same y-intercept and they do not have the same gradient. However, there is an equation that links the gradients. So what we can see is the blue line has a positive gradient, we're sloping upwards. The pink lines are sloping downwards, so they're always the opposite sign. So the perpendicular gradient is the negative reciprocal of the original gradient. Or you may have seen this way of writing it. The perpendicular gradient multiplied by the original gradient will always equal to minus 1. So let's consider some original and perpendicular gradients. So m original and m perpendicular. If my original gradient is 2, my perpendicular gradient will be minus 1 over that original gradient. So minus 1 over 2. My original gradient is minus 3. That's minus 1 over minus 3, which is 1 over 3. My original gradient is 1 over 4. This helps to know the definition of reciprocal, because this will help with fractional gradients. Reciprocal can mean the 1 over, the inverse, or flipping that fraction upside down. So it's still the opposite sign, so in this case we're still going to have then a negative perpendicular gradient, but then this is going to be 4 over 1, or just 4. If my gradient is, say, minus 2 over 3, find the negative of that, so that's going to be positive, and then we flip it upside down, 3 over 2. Now let's look at some questions. Line A has the equation y equals 4x minus 5. Line B is parallel and passes through the coordinates 5 and 40. What's the equation of line B? So, step 1 is identify the gradient. So line B, it's parallel, so we're going to have the same gradient. So we're going to have y equals 4x plus c. The y-intercept will be different. To find the y-intercept, we need to be able to know a value of x and a value of y that lies on that straight line. So next we substitute our known values. So when y is 40, x equals 5. So that is 40 equals 4 times 5, so 4 times 5 is 20, plus c, so c must equal 20. So our equation for line B is y equals 4x plus 20. Let's look at a perpendicular question. Line A has the equation y equals minus 2x plus 6. Line B is perpendicular to line A and passes through the coordinates 4 and 16. We want to know the equation of line B. First, perpendicular means negative reciprocal. So we're always starting with the gradient. So my original gradient is minus 2, so that's minus 1 over minus 2, which is a half. So y equals a half x plus c. We want to find out the y-intercept, which is c, so we need to substitute in known coordinates. When y is 16, x is 4. So 16 equals a half times 4, which is 2 plus c. Take the 2 from both sides, c equals 14. So y equals a half x plus 14. That's our equation of our perpendicular line B.